Ready to stop just writing code and start building skyscrapers? Welcome to the ultimate guide to mastering Azure AI engineering. Most people think AI is just about the glass and steel, the fancy models and the code. But in the enterprise world, the true strength lies in the foundation you can't see. In this course, I'm going to show you how to move from being a coder to becoming a true architect. We'll walk through the entire project lifecycle, from setting the first data bricks to defending your system against security breaches and budget-crushing cloud bills. You'll learn how to handle the waiter that is the API, keep your system healthy with advanced monitoring, and future-proof your work against the shifting sands of model drift. Don't just build a model, build a solution that survives the real world. Stick around, because by the end of this video, you'll have the blueprint to lead any AI project to success. Let's get started. Imagine building a skyscraper. Most people just see the glass and steel, the code and the models. But an architect knows the true strength lies in the invisible foundation. In the world of Azure AI, success isn't just about a smart algorithm. It's about a roadmap that balances security, costs, and real-world compliance. We move through 7 critical pillars, from defining tough KPIs and laying the data bricks, to deploying with standardized code and integrating through seamless APIs. Remember, hitting play isn't the finish line. It's the starting gun for a cycle of constant monitoring and maintenance that keeps your solution standing tall. In AI engineering, security isn't just a layer, it's the foundation. Imagine building a medical AI where a single mistake exposes patient data. That's why we use Azure's defense in depth. We start with the principle of least privilege, using role-based access control to ensure data scientists can build while analysts can only read. To keep passwords safe, we move them out of the code and into the digital vault, or Azure Key Vault, where applications use managed identities to fetch secrets securely. Finally, we stay off the public internet entirely by using private link highways, shielded by firewalls and network security groups. By guarding the gates, we ensure your AI is as secure as it is smart. Think of an API as a waiter in a restaurant. Your application gives the waiter an order, which is the data, and the waiter takes it to the kitchen, the AI service, and brings back your food, which is the AI's prediction. To communicate, we use HTTP methods: get, post, put, and delete. A typical request has a header for access and authentication, and a body with your data, usually sent via simple JSON format. Finally, because real-world systems like servers or the internet can fail, we always build robust solutions with exponential backoff, meaning the system waits longer between retries to avoid crashing a service when an oops moment occurs. AI projects can burn through budgets quickly, often due to zombie resources. Idle computers left running after an experiment ends. To avoid these cloud bill horror stories, we use financial airbags. Microsoft Cost Management acts as your accountant, sending alerts the moment you hit a percentage of your budget. Azure Advisor serves as your consultant, identifying oversized resources you're barely using. We also use tagging to see exactly which department is spending what. Finally, we save by choosing the right power for the job, using significantly cheaper spot VMs for non-urgent tasks, and opting for leaner models like GPT 3.5 for everyday workloads. Once an AI solution is live, the focus shifts to observability, knowing the system is healthy before a customer ever has to complain. We monitor the 4 vital signs: latency, throughput, availability, and error rate. When trouble strikes, we dive into diagnostic logging, using Azure Log Analytics to sift through millions of data points to find the exact moment of a crash. Most importantly, we watch for model drift, where real-world changes, like a sudden heat wave, make old data irrelevant. By retraining our models with fresh data, we ensure our predictions stay accurate, and our skyscraper remains standing tall in a shifting landscape. We began our journey by looking at the foundation of every AI project, the structured lifecycle, where we translated vague requests into hard technical specs and weighed the data bricks through careful pre-processing. We then explored how to deploy and defend those solutions, implementing the principle of least privilege and shielding our data within private tunnels and digital vaults. We learned the art of communication, using the API waiter to handle requests while building in financial airbags to prevent budget-crushing cloud bills. Finally, we committed to constant observability, monitoring the vital signs of our live systems and retraining our models to overcome the inevitable challenge of model drift. Together, we moved from being simple coders to becoming architects capable of building AI that lasts.